In this video, we'll look at some properties of functions. One or a couple of these properties deals with where the function has a maximum value, where it has a minimum value, and where it's increasing and where it's decreasing. So let's look where the function first is increasing and decreasing. Now in this particular function, I assigned some points A, B, C, and D and came up with approximate values for these points. So the location where a function is either increasing or decreasing corresponds to the location on the x-axis. So what we do is we read a function's graph from left to right. So this function is going to be increasing along here, increasing from B to C, and then it's going to be increasing from D and above. So what we would say is this function is increasing from negative infinity up to negative 3.25. Okay, then it takes a break, and then it's going to increase between B and C. So we'll say union. The x value of B is negative 1.5 up to 0.25, and then it's going to increase again once we get to D, so 2.5 and above. So that's where we see that this function is increasing. Now where's this function decreasing? Well, this function is decreasing between A and B, so along here we see the function is decreasing, and then between C and D, let's do that a little better. So between C and D, the function is decreasing. So between A and B, so we're going to say negative 3.25 up to negative 1.5. Then we're decreasing again between C and D, so between 0.25 and 2.5. Then we want to be able to say what the maximum value is and what the minimum value is. So the maximum value, this is the highest point of the curve. So the maximum value is going to be right here. So the maximum value corresponds to the y coordinate. So the maximum value is 5, and it occurs when x is equal to negative 3.25. All right, and then the minimum value, we're going to say the minimum value is down here at D. So the minimum value is 2.5. or rather negative 2, the minimum corresponds to the y value, and this occurs at x equals 2.5. So increasing, decreasing, max and min, when we're talking about increasing and decreasing, this corresponds to the x value. When we're talking about the maximum value, what is the maximum value, what is the minimum value of the function, that corresponds to the y. And the location of where these things occur corresponds to the x-coordinate. One way we can describe a function is by saying that the function is either even or odd. To find an even, or to determine if a function is even, we need the function to be equal to f of negative of the input. So if f of x is equal to f of negative x, we say the function is even. And we would say the function is odd if f of negative x is equal to negative of f of x. Okay, so if the first instance holds true, we say the function is even. If the second instance holds true, we say the function is odd. However, many, and actually probably, well, most functions are neither even nor odd. So these are special instances for a function. Now let's look at a few functions and determine whether they are even, odd, or neither even nor odd. So first of all, here's our function. So for the function to be even, again, we want f of x to be equal to f of negative x. So we already have f of x. So to find f of negative x, we just input negative x into the function. And multiplying this out, we get negative x cubed plus 4x. So here we have negative x cubed plus 4, the original function, x cubed minus 4x. Well, this is not true here. So what we'd say is this is not even, this function, because f of x does not equal f of negative x. All right, now to determine if the function is odd, we want to see, does f of negative x equal negative f of x? Well, we already have f of negative x, that's down here. So all we need to do is find negative f of x. So to do that, we multiply the entire function by negative. And what we'd have when we distribute that negative is negative x cubed plus 4x. And what do you say? This is equal to this. So f of negative x is in fact equal to negative f of x. So because of that, we would say this function, or rather, let's say f of x is odd. Sorry, I was stumbling a bit because I forgot to put an x in here. So definitely we see that negative x cubed plus 4x from the left side is equal to over here. So we see that this function is odd. Let's view another example here. G of x equals x squared plus 5. Is this even? Is this odd? Is it neither even nor odd? So for this to be even again, we want to see if g of x is equal to g of negative x. So we already have g of x, g of negative x. We would say that we have negative x squared plus 5, and we get x squared plus 5. So x squared plus 5 equals x squared plus 5, so that tells us that g of x is actually equal to g of negative x, so we're done. That tells us that g of x is even. Alright, and then let's look at one last one. H of x equals 3x squared over 2x. So first, let's find h of negative x, and we get 3 negative x squared over 2 times negative x. Simplifying this down, we're going to get 3x squared over negative 2x. So what we see is h of x does not equal h of negative x, so that means that this function is not even. And then to check if it's odd, we need to find negative h of x. That's going to be negative 3x squared over 2x. That becomes negative 3x squared over 2x. So this, negative 3x squared over 2x, is equal to this. So what we have is h of negative x is equal to negative h of x, so that means this function is odd. These next few examples are going to talk about the average rate of change of a function. And what we're saying is, if we have a function, let's call this, I don't know, let's call this function f of x. What we want to know is, what's the average rate of change between these 2 points A and B here? Okay, so the average rate of change, we're going to say, is corresponds to the slope of this line between those 2 points. So if we sketch this out a little, we're going to say that this point on the y-axis would be f of A, and this would be f of B here. So what we have, it's kind of like we have two x values, A and B, and then we have two y values, f of B and f of A. So we can think about the rate of change of this function just as the slope of this green line. So how we would find the slope of a line is just y2 minus y1 over x2 minus x1. Well, in this particular illustration, we don't have x and y, we have everything in terms of A and B. So to come up with an expression to find the slope of this green line, which corresponds to the rate of change of this function, we're going to say f of B minus f of A divided by B minus A. So this would be the average rate of change for this function. So let's see how this works with an example. It says, find the average rate of change of f of x equal to minus 3x squared as x changes from 1 to 3. So what this is saying is we have some function, f of x equals 2 minus 3x squared. We want to know what's happening as x goes from 1 to 3. What's the average rate of change? So the expression we saw before was f of b minus f of a all over b minus a. So what we're going to do here is we're going to say, let's say that a is equal to 1 and b is equal to 3. So what we want to do is we need to figure out f of 3 minus f of 1, and then we're going to divide that by 3 minus 1. So we need to figure out what f of 3 is. So we'd have 2 minus 3 times 3 squared. We get 2 minus 3 times 9. We get negative 25 here. And then f of 1, well, 2 minus 3, 1 squared. We get 2 minus 3, which is negative 1. So plugging these into the expression over here, we're going to end up with f of 3 is negative 25 minus f of 1, which is negative 1, divided by 3 minus 1. So we end up with negative 25 plus 1 over 2. That gives us negative 12. So what we would say is the average rate of change of f of x is negative 12. So a second form of finding or of the average rate of change expression is something called the difference quotient. And the difference quotient you will see frequently if you are moving forward and taking calculus. So this is what the difference quotient is. F of x plus h minus f of x divided by h, and h cannot be 0 obviously, or else the function would be undefined if there was a 0 in the denominator. Now this is a much more common expression for the average rate of change of a function, but we can still use this or the previous expression to find the average rate of change. So let's look at an example to see how this works. Okay, so let's find the difference quotient for this function f of x. And we have 3x squared plus 2. So here's the difference quotient. There's kind of three parts, f of x plus h, and then f of x all over h. So let's find f of x plus h first. This is the part that usually gives students the most trouble. So 3. Now wherever we see x, in place of that we are going to input x plus h. So 3x plus h squared plus 2. We end up with 3x plus h times x plus h plus 2. So expanding this out and simplifying, we end up with 3x squared plus 6xh plus 3h squared plus 2. So this expression is going to go right here. So we have 3x squared plus 6xh plus 3h squared plus 2. And then we're going to subtract the value of the function. Well, the f of x is just right here. So 3x squared plus 2, and then we divide everything by h. So distributing in the numerator, this is what we're going to end up with. And at this stage, often we will be able to, not often, every time we're going to be able to cancel some terms from the numerator. So we have 3x squared, that's going to cancel with negative 3x squared, and then 2 and negative 2 are going to cancel. So what we have left is 6xh plus 3h squared all over h. What we'll do is, to simplify this further, we're going to factor out the h in the numerator. And then we can see that those h's are going to cancel. So what's left is 6x plus 3h. And that is the final simplified version of the difference quotient. Why don't we do one more here? So find the difference quotient for g of x equals 2x squared minus 3x plus 5. So again, f of x plus h minus, well, I shouldn't say f here because our function is named g. So g of x plus h minus g of x all over h. So let's go ahead and find g of x plus h first. So 2x plus h squared minus 3x plus h plus 5. So let's go ahead and expand that. And this is what we end up with. Again, this expression goes right here in the difference quotient. So what we'll have is 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5, and then we're going to subtract the value of the function. So we're subtracting g of x. So minus 2x squared minus 3x plus 5, and that all gets divided by h. So from here, let's just simplify the numerator and see what can cancel. So what we see is that negative 2x squared and 2x squared cancels, negative 3x and 3x cancel, and then 5 and negative 5 cancel. So that leaves us with 4xh plus 2h squared minus 3h all over h. Again, let's factor out the h. 4x plus 2h minus 3 divided by h. The h's cancel, and we are left with 4x plus 2h minus 3 as the final simplified form of the difference quotient.